Hi, and welcome to the first practical tutorial in the LLM evaluation course. The goal is to show you different LLM evaluation methods and how you can implement them using a simple toy example. This tutorial will be split into three parts. First, we will show you a single evaluation end-to-end so that you understand the base API that we're going to be reusing every time we run all the other evals. Then, we're going to look at the reference-based evaluation methods where you compare the answers you get against the ground truth and different ways how you can do that. Third, we will look at the reference-free evaluations, where you judge the responses as they come, and show you different ways how you can do this using methods from LLM judges to machine learning-based scoring to regular expressions, and we'll implement a bunch of different criteria to show you how you can do this. Let's dive in. I will be running this tutorial in Google Colab, but you can run it in any other Python environment or Jupyter Notebook. The first step is to install Evidently, which is an open source Python library, so normally you can install it by running pip install evidently. However, in this case, I'm installing it also with the LLM extras because we're going to use a lot of different LLM evaluation methods and I need a few additional dependencies. Here's the structure of our tutorial. It's going to be pretty long. For now, let's start with the first part, which is the anatomy of a single eval. We also need to run a bunch of imports. In this case, we need to import everything we're going to use until the very end of the tutorial, so you will see how we use each of the components down the line. To run our basic evaluation, we need to first prepare the dataset. In this case, we are directly generating this dataset right here, and we include some questions and answers. Let's take a look at the dataset right here. So here it is. We can come up with a few things that we can evaluate, but for illustration, we can look at something very simple like text length. To be able to run evaluations on top of this dataset, we first need to prepare an evidently dataset object. This basically converts it in a way that we can further process. To create this dataset, we also need to pass something called data definition. In this case, the data definition is something that lets you point to specific columns in your dataset and explain their role and type. For now, we're just specifying that we have text columns in the dataset, which is question and answer. This is useful because sometimes you might also have numerical or categorical metadata, or maybe you have specific roles within your columns like prediction and target, but for now we're just going to go with that. The next step is to create this evidently dataset object. We do that by passing this data frame that we just generated and passing this data definition. So here it is. Now, here's an important part. To run evaluations within the Evidently library, we need to create something called descriptor. A descriptor is a row-level evaluation which adds an additional score or label to each row in your dataset. In this case, it can refer either to input or output and assign a specific quality, starting from simple things like text length to maybe categorical judgments which are provided by the LLM as a judge. This is a universal interface that we're going to reuse to implement all sorts of evaluations. We use this as a separate thing from metrics, in which case a metric is a dataset level evaluation. So for example, we can compute accuracy or precision or recall of a classification, and we do this on the whole dataset. Whereas when we compute descriptors, we actually do this on the row level. We can still aggregate the overall results, and you will see how, but for now, let's make this distinction. As a simple evaluation, we're going to run the text length evaluator. In this case, we're going to use the add descriptors and then actually pass the list of descriptors that we want to implement. We have a bunch of descriptors already implemented evidently, and if you go to our documentation, you can actually see, well, quite a few. They span from these deterministic evaluations to LLM judges, so it's all the same interface. For now, we just pick one, very simple, called text length. When you include the descriptor, you also need to specify to which column you want to apply it to. In this case, we want to compute the length of the answer. And we give it a name, so answer length. So here it is. And you can see we can preview the results almost immediately. So we got this additional column that was added to our dataset, which says answer length. So here it is. There's one more thing I want to show you. In many cases, you not just evaluate the number, you also want to get some sort of a pass-fail decision on top of this number. So maybe there are some responses which are too long, and you want to detect if there are such responses. To do this, you need to add additional tests to the descriptor that you're computing. So in this case, we are specifying that our condition is if the text length is greater than or equal to 100, we consider it to be too long. So in this case, we will get a true for our test condition, and we will see all the responses which satisfy this condition. We will call it the answer is too long descriptor. You can also notice that this time I'm running this all together. So I'm creating the data frame, adding descriptors all together in one go. And here it is. We can notice that we added now two columns. So one was the original descriptor with text length, and the other one, which is the test result, which basically says us true or false for this condition that we specified. Now, after we run the evaluation, we might want to summarize the result. For now, we just looked at data frame, which is fine if you have a few inputs, but if it's a very big data frame, it's probably not very convenient to look at this just with your naked eye. So evidently we have a thing that is called a report, which lets you summarize or compute additional metrics on top of the complete data frame. In this case, we're going to create a report and pass something that is called text evals, which is a preset that lets us summarize all the distributions on top of these columns that we just computed. Then we need to run this report on the data frame that we have. In this case, this is a data frame with all the added descriptors that we already computed. So let's run it and let's preview the result. The fun part is that you can actually look at it directly in your Jupyter Notebook or Colab environment. In this case, you can see that we generated the visualization with the distribution of the score that we computed, in this case the text length, and we also see the distribution of the pass-fail result on top of this is the answer too long check. You can also see a bunch of additional metrics which can be useful, like the minimum, maximum, mean value, and so on. Now, there are other output formats that you might want to use. If you're running an automated check, you might want to generate a JSON or maybe a Python dictionary so that it's easy to consume the results in some other pipeline beyond that. You can also store the evaluation as an HTML file. In this case, you will be able to just store it somewhere and then open in your browser. So I just did download this HTML file, and here it is. You can open and look at it. Now, there is one more thing we can do. If you run a lot of evaluations and you want to store the results or compare them over time or monitor if you're improving or not, you can also send them to Evidently Cloud and track them there. In this case, you first need to create an Evidently Cloud account that is free to sign up. Once you have the account, you can go to Evidently Cloud and you can get a token so that you can interact with the Evidently Cloud from your Python environment. I already have it all set up, so I can just directly connect from here. The next step is to create a project. You can actually do this directly in the UI. So if you come here, you can create a new project, call it something, and then you can just have one new project right away. Now, we just created this project. If you open this project, you can also copy the ID and then use it to connect from Python environment. But as I just said, alternatively, you can also create the project from Python. Now, we already connected, so all we can do is now send the results to Evidently Cloud. In this case, we are sending this exact report object that we just generated and looked at, but we are uploading it to Evidently Cloud. So if you go to Evidently Cloud, you can open here the report section, and you will be able to see the report that we just generated. You can see the same visualizations that we just looked at, and below that you can also see the data set, and you can, for example, explore or sort the results or somehow interact with this. One more thing you may want to do is to add a dashboard. In this case, if you go directly to the main dashboard, you can enter the edit mode and then add tab and choose columns tab. And this columns basically summarizes all the descriptors or column summaries that we have in the data set. Right now we have only one single evaluation, so each of these have a single data point. But if you, for example, run and rerun these evaluations, you will see how you progress over time. And if you come here, you can always go down and open the original report to explore. In the end, if you're running a bunch of evaluations, you can get something like this, where you will be able to track different metrics over time to see if you're improving or not, and analyze how in general are you doing across your quality dimensions. Now, this is all I wanted to show in terms of a basic evaluation workflow. You can reuse the same descriptor interface to run all sorts of evaluations, not just text length, but something very complex like LLM judges too. Let's take a look in the second part of the tutorial.